Welcome to Across the Globe. Today we will learn about basic descriptive statistics. Descriptive statistics serve the purpose of summarizing and describing key features within a dataset. By leveraging this statistical method, analysts can gain insights into the central tendency, variability, and distribution patterns exhibited by the data. For instance, a retail company may utilize descriptive statistics to comprehend the average sales figures across its stores, the range of variability in these sales numbers, and the distribution of sales data to identify high and low performing locations. Such statistical techniques facilitate a comprehensive understanding of data characteristics, enabling informed decision-making processes. Measures of central tendency are statistical measures that help to summarize a dataset. The mean is calculated by adding up all the values in the dataset and then dividing by the total number of values. For instance, if we have test scores of 70, 80, and 90, the mean would be 70 plus 80 plus 90, whereas 3 equals 80. The median is the middle value when the data is arranged in ascending order. For example, for the set of values 3, 5, 9, 12, 18, the median is 9. The mode is the value that appears most frequently in the dataset. In the set 3, 5, 9, 9, 12, 18, the mode is 9 because it appears twice, which is more frequent than any other value in the dataset. These central tendency measures aid in understanding the distribution and characteristics of the data, enabling better decision-making and analysis in various fields like finance, healthcare, education, and research. To calculate the mean of a dataset in Python, you can use the NumPy library. First, import NumPy as NP. Then, create a list of data, for example, 10, 15, 20, 25, 30. Calculate the mean by using np.mean_data, where data is the list of values. Finally, print the result to display the mean. In this case, for the dataset 10, 15, 20, 25, 30, the mean is 20.0. Measures of variability such as range, variance, and standard deviation are essential in analyzing data spreads. Range is computed as the disparity between the highest and lowest values in a dataset. Meanwhile, variance quantifies the extent to which data points deviate from the mean. Standard deviation, which is the square root of the variance, presents a more intuitive metric of how dispersed data points are from the mean. For instance, in a sales report, the range could help identify the difference between the lowest and highest sales figures, while standard deviation could indicate how sales performances deviate from the average value. To calculate the standard deviation of a dataset in Python, you can use the NumPy library. This library provides the function np.std that computes the standard deviation. For example, if you have a dataset with values 10, 15, 20, 25, 30, you can calculate the standard deviation as follows. Import the NumPy library using the statement import NumPy as NP. Define your dataset, for instance, data equals 10, 15, 20, 25, 30. Calculate the standard deviation by using stestddev equals np.sddata. Finally, print the result by using the print function, which will output the standard deviation to the console. In this example, the standard deviation of the dataset, 10, 15, 20, 25, 30, is approximately 7.07106781865755. Skewness and kurtosis are statistical measures that help understand the shape of a distribution. Skewness indicates the symmetry of the distribution. A positive skewness implies a longer right tail, while a negative skewness denotes a longer left tail. For example, the salary distribution of a company might exhibit positive skewness if a few employees earn significantly more than the majority. On the other hand, kurtosis measures the heaviness of the tails of the distribution. High kurtosis indicates heavy tails, which means the distribution has more extreme values. For instance, a financial returns distribution with high kurtosis might have more outliers indicating higher volatility. Conversely, low kurtosis signifies lighter tails and fewer extreme values. To calculate the skewness of a dataset in Python, you can use the SciPy library. The skewness of a dataset measures the asymmetry of the distribution. For example, in a dataset of 10, 15, 20, 25, 30, the skewness is calculated to be 0.0. Skewness is a statistical measure that reflects the symmetry of a distribution. A positive skewness indicates a tail on the right side of the distribution, while a negative skewness indicates a tail on the left side. In our example of 10, 15, 20, 25, 30, with a skewness of 0.0, it indicates a symmetric distribution with no skewness. Descriptive statistics offer a summarized view of data showcasing central tendencies, spread, and shape of a dataset. This analysis aids in grasping the distribution pattern and identifying outliers or patterns within the data. Such insights inform decision-making processes in various fields, like finance, where analyzing stock prices variability helps in risk assessment. Inferential statistics, building upon descriptive statistics, enable drawing broader conclusions about a population using sample data. For instance, in marketing, examining a sample group's feedback on a new product can lead to inferring consumer preferences within the larger market. Such statistical methods empower professionals to make informed predictions and strategic choices based on data-driven insights. Basic descriptive statistics is like looking at a recipe to see the list of ingredients and their quantities before starting to cook a dish. In a program, basic descriptive statistics is like examining a dataset to gather information such as the mean, median, and mode before performing any further analysis or calculations. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. In this code snippet, we start by loading the necessary library dplyr for data manipulation in R. We then read the dataset from a CSV file named data.csv into a variable called data using the read.csv function. To get a glimpse of the dataset, we display the first few rows using the head function. This provides insight into the structure and content of the dataset. Next, we generate summary statistics for the dataset using the summary function. This includes key descriptive statistics such as mean, median, minimum, maximum, and quartiles for each numerical column in the dataset. After that, we proceed to calculate three central tendencies. The mean value of a specific column is calculated using the mean function. The median value of the same column is calculated with the median function. The mode value, which represents the most frequent value in the column, is calculated through a series of operations that involve sorting and counting occurrences. Finally, we print out the calculated mean, median, and mode values using the cat function. This allows for easy interpretation and comparison of the central tendency measures. Overall, this code showcases the application of basic descriptive statistics techniques to extract meaningful insights from a dataset, much like analyzing ingredients and quantities in a recipe before cooking a delicious dish. One industrial application of basic descriptive statistics can be found in the manufacturing industry. In a production facility, managers often use descriptive statistics to track the performance of production lines. By analyzing metrics such as mean production output, median defect rate, or mode of machine downtime, managers can identify areas for improvement, optimize processes, and ensure the overall efficiency of the manufacturing operation. Another real-world example can be seen in the retail sector. Retailers frequently utilize descriptive statistics to understand customer behavior and preferences. By examining metrics like the mean purchase amount, median shopping frequency, or mode of popular products, retailers can tailor marketing strategies, optimize inventory management, and enhance the customer shopping experience to meet consumer demands effectively. Across the globe, basic descriptive statistics play a crucial role in various industries by providing valuable insights, enabling informed decision-making, and driving continuous improvement. Keep learning, stay curious, and I'll catch you in the next video.